Hey guys, welcome back to the channel and another video. And quite interesting today. We are in A.T.L. For those who don't know where I'm at, this is the Buckhead Library. So a lot of cool things. They even got this nice little statue here. While I go and get ready for some business meetings that I got in this library, you guys are going to be learning about file permissions in a Unix-like system. Make sure you go ahead and like, subscribe, and turn on your notifications. And I forgot to mention, share with a family member or friend. So as I said, while I go prepare for my business meeting, you guys are going to go learn file permissions in a Unix-like system. And I'll see you guys on the other side. Welcome to my desktop, where we're going to learn all about file permissions in a Unix-like system. And I got this nice little whiteboard up here, so bear with me. I'm using this fancy little virtual pen here where we're actually going to go through this example together and we're going to learn. So if you see some horrible handwriting, don't make fun of me. I'm trying. Hence why I was an engineer and why I always started typing instead of writing. Anyways, with that out of the way, let's jump on into the example for today. When you first log into a Unix-like system, you're gonna be a user. And one of the things that you're gonna see in this example is I actually added 3 users to our machine. We'll write the user out so that way you can see all these examples. So we have Aiden, who's our first user, Amelia, who is our second user, and then we have Jess, who's going to be our third user. Let's say I were to log in as Aiden. I created a group called Acosta E.T.F. Aiden and Amelia are part of that group. Now, sadly, Jess wasn't cool enough to be part of the group, so she is just going to be out here all by her lonesome self. Sorry, Jess. So now, whenever we're logging into a Unix-like system, right, there's 3 things that we have to consider whenever we're looking at file permission. The first thing that we're going to consider is who is the owner of the file. Now, the other thing to consider is the group. So the person who created the file, are they under a certain group? And then the last thing that we want to consider is others. That means everybody else. So remember, again, we're logged into the Unix-like machine using the name Aiden. So let's pretend Aiden wants to create a file, right? So we're going to use the touch command, and let's just say file1. Aiden was the one who created that file. So now this file1 that Aiden created, he is now considered the owner. So then when we're saying, hey, under owner, we have read, write, execute. That's the file permissions here. Then under groups, we have read, write, execute. And then under others, we have read, write, execute. These permissions have to all align, and typically they all align by whoever created the file, or if you're the root user is allowed to change these permissions at any time, right? That's the other thing to consider. When we hear, for example, the permissions are wide open, and sometimes you'll see an industry where they'll say, hey, 777, huge security flaw, but anyways, these permissions are wide open. How do we know that, right? We don't know if that's the case, right? So one of the things that we can do is figure out how these 777s that you see here translates into wide open permissions for the owner, who's Aiden, the group that he's a part of, which is Acosta E.T.F, by the way, and then others, meaning anybody who is not the owner, which is Aiden, anybody who's not part of the Acosta E.T.F group. So that means you're in the other section, which is where Jess is. So how does 777s translate into open permissions, right? That's the big question here. So one of the things that we can do is understand how computers work. And they work on what's called binary. And so binary basically says that, hey, you can either be in either 2 states. You can be either a 0 or you could be a 1. And 0 basically means that it's off, and 1 means that it's on. That is really the gist of it, right? In a simple version of it. How do we translate all these 7s to mean that we're opening up the permissions for everybody? Well, you have to apply that now into its binary format. And we can do that by going under each group and then assigning what it would be. So let's take a look at this example and walk through it so that way you can understand what I mean. So remember, Aiden created a file by using the touch command and he called it file1. So for him, he's going to say on the file, and a lot of the times you'll see this in industry, is chmod 777. He'll run this command on the file, and then what that does is it's going to say, well, for read, I want to be able to turn it on, right? It goes back to our binary right here. For write, we want to be able to turn that on. And for execute, we want to turn that on. Let's go ahead and do the same thing for groups, right? Anybody who's in the Acosta E.T.F group, that means Amelia, who's part of that group, will also have this permission because she's under the groups. So read is 1, write the file is 1, and then execute the file is 1. Now, everybody else in the outside world, right, who's not part of the group or the owner of the file, they will also have turn on for read, turn on for write, and turn on for execute. Now, you may be asking yourself, okay, well, I see all these, ones here, right? Because we want to activate read, write, and execute for everybody. Well, how does that translate into the 7s? That just doesn't make sense. And so that is what's called binary math at this point. And so if you actually do the math, 1, 1, 1 in binary is actually equal to 7. And so I'm going to teach you a tool that you can use in order to be able to verify this if you don't want to take my word for it. So one of the coolest things that you can do if you're on Windows, and I'm sure Mac OS has this as well, you can launch your calculator. And so one of the things you can do is click the navigation button here. And then if you notice, you have standard, scientific, graphing, programmer, date calculation. A lot of really cool things in here. The one that we're interested in is programmer. And so it has hex, decimal, octal, and bin. So one of the things that we can do is we can actually click on decimal, put the number 7 here, and then go ahead and click on binary, BIN. Well, what do you know? The calculator actually translated it for us, so that way you don't have to take my word for it. You can actually see here, 7 is 1, 1, 1. So now that we verified it, right, let's go back to our example here. Let's make this a little bit smaller. So as you can see here, I have triple ones, right? That's where this is. And whenever I say chmod 777, right, what we're going to be doing is we're going to be putting a 7 for owner, a 7 for groups, and then a 7 for others. So in this case, right, it goes back to what we have over here. So the owner has read, a 1, so we activated it, right? Write has a 1 because we activated it by putting the 1 there. And then execute has a 1 as well. And then you just do the same thing for the groups. And then you do the same thing for the others. So meaning that this file that Aiden created called file1, everybody has the ability to either read it, write it, or execute the file. Pretty cool. Let's do one more example so that way we can actually understand this. Let's get our calculator out of the way here. So now Aiden decides to create a file again, right? He calls it file1. But this time he runs the command chmod 755 on it. So now if we translate that into owner, group, and others, 755, what does that mean? For our first number, 7, that goes into our owner, we've did the math before, so we already know that the owner has read, write, and execute permission. So now the question is, well, what is 5 in binary? So what we're going to do is let's bring in our fancy little calculator back again. And let's click on decimal, click on the number 5. And then after that, you can start to see under binary, BIN, it gives you the answer. So the answer is 101. Right? Because we only need the 3 bits. We don't need the 4th one. We just verified on our calculator that 5 in binary is 101. So now we can attach these permissions to our group and then our others. 101, 101. Now let's kind of go through this real quick just to make sure it makes sense. So remember, Aiden touched the file. He did chmod 755. Now, this is what it translates to in binary for owners, group, and others. So remember, he's the owner of the file. So he has read, write, execute. They're all ones, so it means that the permission is on for read, write, and execute. Now let's go into the groups. Now remember, anybody who's associated with the group, in this case, he's part of the Acosta E.T.F group. And if you see here, Aiden and Amelia are in that group. So this group has read, execute, and then now we move on to the others, meaning if you're not part of this group, and we have Jess here all by her lonesome self, Jess has read, she doesn't have write, and she has execute. Now here's an interesting question you may ask. Well, what happens if, for example, Aiden is part of this group, but you're saying that if he is part of this group, here as an owner, he has write permissions, but in the group, he doesn't have write permissions, right? Which one takes into effect? Well, what takes into effect is actually the owner, because he's the owner of the file. So even though he's part of the group that doesn't have write permission, Aiden will still have write permission because he's the owner of the file. Unlike Amelia, Amelia's not the owner of the file, so she falls under groups and she wouldn't have any write permissions. So she's not allowed to write to the file. So now here's the interesting thing, and I want you guys to put this in the chat for me. If Aiden, who's the owner, right, he is typing on his terminal, he's going to say touch file 1. After he touches the file and creates it, he's going to do a chmod 744 on file 1. So put in the comments what you think the permissions are using chmod 744, and hopefully you get that one right. All right, so now that we went over all those things in the theory world, right, let's actually put it to practical use. And here in front of me, we have our machine that we're running, right? And we're running it in the cloud. We're running Red Hat. And as you saw from our example, we had 3 users. We had Amelia, as you can see here. We have Aiden, and then we have Jess. In our example, Amelia and Aiden are in the same group, and we can see that by running the groups command. And we can see that Amelia is part of the Acosta E.T.F group, and she's also part of the Amelia group as well. Same thing here. For Aiden, Aiden is part of the Acosta E.T.F group, and he's also part of the Aiden group. Now let's take a look at Jess. Jess is only a part of the Jess group. She's not a part of the Acosta E.T.F group. Now remember, based on our example, our first example, Aiden created a file, and he created a file using the touch command. And he called it file 1. One of the things that we're going to do is we're going to take a look at the permissions of file 1. So as you can see here, here is the owner, which is Aiden. The group which he's under is called Aiden as well, but we're going to change that to the Acosta E.T.F group because we want to make sure that anybody who's associated with that group, hint hint Amelia, will be able to also have the same permissions. So we do that with the change group command. So let's take a look at the permissions again. And as you can see now, Aiden, who's the owner of the file, and the group that's associated with this file now is called Acosta E.T.F. And then we have read, write, execute, read, write, execute, and then only read and execute here. But our first example was read, write, and execute across the board for what is our owner of the file, groups of the file, and then everybody else who is not in the group. So let's go ahead and change that. And we do that using the change mod command. So chmod 777 file 1. Now let's go ahead and take a look at the file again. And we can see here that the owner, which is Aiden, he has read, write, and execute permissions. The group, which is Acosta E.T.F, anybody associated with that group, has read, write, and execute based on the 3 in the middle here. And then everybody else, meaning everybody who's not associated with the group, has read, write, and execute permissions. So let's go ahead and see that that actually works. So now that we're in the file, let's go ahead and write something. Hello, Amelia. This is file 1. And what we can do also too is let's go ahead and address Jess as well. And just so we know what we did for the permissions, I'm going to put the permissions right under it so that way we can keep track of that. See, chmod 777, right? Let's put some nice little lines here. And we could say from Aiden. All right, so now let's see if everybody can read it. So Amelia should be able to read it, right? She's part of the group, and part of the group has read, write, and execute permissions. And we verified that over here. And that actually works out to be true, right? Amelia, this is file 1. Hello, Jess, this is file 1. And we can see the command, and then we also see what Aiden wrote. So now let's see if Amelia can write to it. Hello, Aiden, this is Amelia. So looks like Amelia was able to write to it. And how do we know? Let's go back into Aiden and see. There it is. Hello, Aiden, this is Amelia. Now, Jess should also be able to read and write to the file based on the permissions. So let's go and verify that. There it is for reading. We're going to do this for Jess, and she should be able to write. Now let's verify that with Aiden. Perfect. We see here that Amelia wrote to the file and Jess wrote to the file. Now, how do we make sure that only people in the same group and also the owner of the file is only able to write and then everybody else doesn't have the ability to write? That was 7-7 because the owner is wide open permission, the group is going to have wide open permission, and then everybody else, others, is not, right? They're going to only have a 1 for read and a 1 for execute and 0 on write, which turns into a 5. So let's go ahead and run that command now. So as we can see here, the owner, which is Aiden, has read, write, and execute permissions. The group, which is Acosta E.T.F, has read, write, and execute permission. And then everybody else only has read and execute permissions. And remember, Amelia is part of that group as well. So Amelia should, in theory now, based on these permissions, have access to read, write, and execute. Let's go ahead and prove that out. Let's go into file 1. And we are going to say 755. This is the new one now. Hi, Amelia. You still have access to write. And then we can say, sorry, Jess, you do not have access anymore. Sorry, Jess. So now let's make sure that the permissions actually work. Let's read the file. Perfect, that works. I see the new thing here. It says, hi, Amelia, chmod 755. That's the command that we ran on it, right? You still have access to write, which is Amelia. And then, sorry, Jess, you don't have access anymore. So let's see if Amelia has the ability to write to it. Hi, Aiden. I can write to the file. Well, what do you know? No errors there. So let's head over now to Jess, right? Jess should be able to see the changes that Aiden did and also Amelia because they both wrote to the file. And what do you know? There it is. Hi, Aiden. I can write to the file. Now let's add a little bit something extra in case people didn't know who wrote what was what, right? Amelia. And this was from Aiden. Let's do that again. And as you can see, the changes are there as well. So hi, Amelia, and hi, Aiden, right? So it tells you who wrote who. Now to prove that our permissions still work, right? Let's see if Jess can write to the file. As you already can see, the editor is already telling me that we're having an issue as it's only a read-only file. But let's continue and see what happens. It's already giving me a warning. Hello, this is Jess. Let's see if we can write to it. It's telling me it's a read-only, and it wants me to use exclamation to override it. Let's see if we can override it. It's even telling me can't open the file for writing. And as you can tell, we're not going to get anywhere very quickly with the permissions that we have set. So let's go ahead and quit out of this. And that is how we verified what we did in our theory when we were in the whiteboard, how it translates to the actual real world, and how file permissions work in a Unix-like system. Hey, so welcome back. I'm glad you guys actually had the opportunity to learn about file permissions in a Unix-like system. But after watching the video, you should be able to understand it and you should be an expert at it by now. But if you're not, make sure you watch the video over and over again, because remember, repetition is key. You'll learn eventually in time. So if you need another refresher, go back, watch the video, and you'll be all set from there. So that'll do it for me in this video. Thanks for watching. Go ahead and make sure you give me a thumbs up. Also, don't forget to subscribe to the channel. Don't forget to share the video with a friend or family member who is also interested in learning about file permissions. in a Unix-like system. And be on the lookout. We got a lot of cool videos coming with engineering, technology, and finance. And I'm gonna head back to Florida now after a good week in Georgia, ATL. So I will see everybody on the next video.